Section 2.7 has to do with proving segment relationships. We're going to learn more theorems and postulates that we can do more proofs with. The more proofs you do, the better you get at it. So postulates and theorems that can be used in algebraic or geometric proofs once they are presented. The ruler postulate, you can read through that, but it just basically says that if you have 2 points, you can use a ruler to measure the distance between those 2 points. Segment addition, basically if you have a B that is between your A and C, I'm going to switch here, then I can say that the segment AB plus the segment BC is equal to the whole segment. So this part plus this part equals the whole thing. So that's called segment addition. 2 parts added together give you your whole. Theorems of congruency. Basically, you've had these before, but they haven't had the congruency on them. They've been theories of equality. So all that has changed on reflexive property is I put a congruency mark there rather than an equal sign. So AB is congruent to AB. Symmetric property, if AB is congruent to CD, then CD is congruent to AB. The transitive property is if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. Now each of the properties that we just talked about can be used in our proofs when we do deductive reasoning. So here's our first proof. Basically, you want to make sure your given is written down. You want to make sure your illustration is written down, and then you're going to do your 2 columns. You remember to label the first one statements, and the second column is labeled reasons. The very first thing you're going to do is write down your given. JK is congruent to KL, and HJ is congruent to GH, and KL is congruent to HJ, and that's given. What we are trying to prove is that this GH is congruent to this JK. That's what we want to end with. Now there's a good chance that we're either going to use segment addition or we're going to do transitive property. If you look at the way that you've got this thing laid out, if this is congruent to KL and KL is congruent to HJ, then through transitive property, I can say that JK is congruent to HJ. That's transitive property. Now, that gives me my JK that's down here. So then I turn around and I look at this in comparison to this. JK is congruent to HJ, and HJ is congruent to GH. So my third step is JK is congruent to GH, and that is, again, transitive property. Now, the thing is you begin a proof and you just start going in a direction that you think you can go. Sometimes you have to back up and start again, but this one's should be making some sense here. We've just used transitive property. Notice we're almost there, but my last statement has to completely match what I'm trying to prove. So I have to switch the order here, and I have to go GH is congruent to JK, and I'm allowed to do that because of symmetric property. Symmetric property says I can just switch sides. All right, so that's that proof done. I was trying to prove that GH is congruent to JK, which is what we did, just using transitive property. But you have to give a reason for everything you do. All right, here's another one. Now notice these do not have congruency marks, and they don't have lines over top of them. But what we have here is we're saying that PR is congruent to QS. So that's what we've already been given. What we're trying to prove is that little part is congruent to that little part. Now, good chance that this one is going to have to do with segment addition. Let me explain that once I get the first step written down. So PR is equal to QS, and that's your given. If you notice, what this and this have in common is that little section right there. So I can come over here and do segment addition and say PR is equal to PQ plus QR, and at the same time I can say RS is equal to, oh wait a minute, not RS, QS, sorry about that. QS is equal to RS plus QR. Okay, and that is simply segment addition. Okay, now what I can do on my third step is, rather than writing PR, I can write what PR is equal to. So I have PQ plus QR, and rather than writing QS, I can write what QS is equal to, RS plus QR. And that is substitution. So rather than writing the PR, I substituted in what it was equal to. Rather than writing the QS, I substituted in what it was equal to. Now, if you look here, they each have this QR in common. So I can subtract QR from both sides. What I do to one side, I have to do to the other side. It's just like with numbers, but now I've just got letters. And so what I did was I used the subtraction property, which is what I've used in algebraic proofs often. Okay, and then what I'm left with is PQ, okay, because those cancel out, equals RS, and that is substitution. I just wrote the answer to that and the answer to that. And I have just proved what I was trying to do. Okay? Now, don't worry if you're still struggling with this. The more you do them, the more they follow like patterns, and you'll remember the pattern from another proof. All right. So let's do this proof. Now notice this one has on the congruency thing. So we're going to have to add a little step to this. But what I have is I have PQ, which is this, is congruent to RS, and I have that QS is congruent to ST. And what I'm trying to prove is that whole part is congruent to that whole part. So there's my two columns here. All right, first step, I write down my given, PQ is congruent to RS. You'll notice in the book sometimes they separate the given and put them on two separate lines, but I always just put them all together at the beginning of the proof. All right, that is given. I'm going to have to do a little math on this, and when I do math on segments and I have congruency, I have to take the congruency off. Now on that one that we just did, notice it doesn't have any congruency, so I didn't have to do that. So when you have the congruency mark and you're going to add segments together or subtract segments or do any kind of math on them, The first step is taking off that congruency symbol. Okay, and that is simply definition of congruency, because congruency means they're equal to each other. So now I can do math on this. So I'm looking here and I'm going, well, how about segment addition? I can say PQ is equal to, or not PQ, PS, that whole thing. PS is equal to PQ plus QS. Okay, this whole thing is equal to this plus this. I can also say RT is equal to RS plus ST. And those are segment addition. Now, notice though that I can substitute here. I know that PQ is equal to RS, and I know that QS is equal to ST. So I can turn around and say PS is equal to RS, which is the same thing as PQ, plus ST. So I substituted this for this and this for this. So that's substitution. Now, if PS is equal to this and RT is equal to that, I can turn around and just substitute RT right there for my RS plus ST. So I have PS is equal to RT by substitution. But that's not exactly what I'm going for. I still have to put the congruency mark back on. So now I go PS is congruent to RT, and that is by definition of congruency. All right, your homework on this is page 104 through 105, 12 through 18 all, plus 20 and 22. Now these two are proofs. Now, this is going to be difficult. I just encourage you to do what you can do with it, see how far you can get, and the more you do them, the better you're going to get.